Swayam Prabha. Digital India. Educated India.
What is the profile? What profile is the best for me? So this is where the concept of minimum moment comes in. So remember, what we are trying to do is get as flat a profile as possible of the resource, and this is ideal, but we want to get it as close to this as possible. And if we go back and look, one way of expressing this, so while I can visually look at different profiles and then say, oh, this is the best profile for me, to kind of use a mathematical approach to say, to kind of zero in on the best profile, we use the minimum moment. So we say the moment of this shape about this axis, okay, is minimum only when the profile of the resources are rectangular. So to put it another way, if I had a profile, going back a few here, if I had a profile like this, and I am going to start leveling it, there is obviously I cannot get a perfectly rectangular profile, but given my total sum of resources, once I level it in a way where my floats are used appropriately, the best leveled profile will have the minimum moment for the whole histogram. So that is the basis of the minimum moment algorithm, and or the minimum moment metric which we are going to use. And when we look at, if we take an example here, so here we have just two resources, okay, two resource profiles for 2 days. One is 4, the other is 12, okay, the total is 16. And if I am going to take the moment of this about the x-axis, it's 4 into 4 by 2, that is the moment of this, that is the height into the height divided by 2. So this is the moment above of this rectangle. Similarly, the moment of this rectangle is 12, that is the height, multiplied by 12 by 2, okay. So this is the moment of this rectangle. If I sum this up, I get the moment of this histogram, which is 80. Now for the same resource requirement, which is 16, 10 plus 6, I have an alternate histogram here. So here you have, the moment of this is 6 into 6 by 2 plus 10 into 10 by 2, okay, and this is the moment of this histogram. And you can see as my my peak reduced, my moment also reduced. And obviously, because this is square of the height of the bar, you are going to, as I reduce it, it reduces by the square. Now I have an 8 and 8, okay, which is again 16 total resource units, and I have this, so obviously 8 into 8 by 2, that is 8 by 2 here, this is the moment, and 64 is the value I get, and this will be for 16 units of resources distributed between 2 days, this will be the minimum value of the moment of this histogram. So based on this is the concept we would like to use to explore how resources can be leveled on our projects, okay, or at least if it's not on our projects, on the kind of idealized projects which we would like to do. So when we look at doing the minimum, when we look at the moment, applying the moment again, so here is the earlier example. Now this is a slightly different histogram than the early start. You will see that we have activity H that has moved by 1 here. So if you look at the histogram, you can see here, if I calculated the moment of this histogram for activity D starting from here to here, which is loading this set of days, and the moment is 327.5. Now what we have done here is shift 4 all the way here, Okay, it's moved from here to here, moved shift 4 all the way there, and you can see the resource profile changes and the moment of the whole histogram has reduced. So when we are looking from a leveling perspective, especially for a rectangular kind of a shape, we are saying this level, this histogram is better than this because it has a lower lower moment, and it has a it is more towards a rectangular profile than this, and this metric gives us that justification that this is more profiled towards rectangular than this. Okay, so using this as a basis, we now want to be able to go through, for example, apply this in a very more stepwise systematic way. So I am just again repeating, the concept is to reduce the moment of the histogram in a systematic way, and once we get to the minimum moment, we say that is the best profile, or that is the profile as closest to a rectangular profile which we would like to get. So as we move, so when we move from here to here, I can certainly calculate my my moment as it is, but what we want to do is work towards a procedure that can kind of give us a methodical way in being able to calculate whether a shift improves or does not improve the rectangularity of the resource loaded histogram. So when we move to the procedure of when we want to develop a procedure, we need a metric. So if we go back and look at the earlier function where we said there are 50 options, one way is to actually calculate the moment of the 50 different alternatives and then certainly take the minimum of that. That will certainly give you an answer, but the computational effort of calculating for 50 alternatives might be too high. Of course, 50 alternatives is not high in this case, but if you had several 100 activities with several different days of float, it could certainly blow up into a very large figure which is not easily computable. So to be able to find out how we go about whether something should be improved or not, they've developed something called an improvement function. So what an improvement function tries to do is to, rather than calculate the moment every time, if there is an activity here, for it to be moved to across its float, each time it tells you whether the movement you are doing is causing improvement. By improvement we mean by reducing the moment of the histogram, or is it causing an increase in the moment of the histogram. Okay, so this improvement function, we will get a little bit into how the improvement function is formulated. So you have here a histogram, and you can see that as we move this across to this side, there are resources that are taken from a certain set of days and moved to another set of days. Okay, so these resources actually moved here, and that's what's showing up here. Now when we are defining this, there are a few variables. So xi is the resource level from, so xi is the resource level from which resources were moved. Okay, so this is xi, so this level is xi, and m days of resources are moved. So here in this case m is 3, so 3 days of resources were moved. Okay, and wi is the resource level to which the m days of resources. So wi is these days. Okay, this is the original, before moving it was xi wi. So this is, I am going to write it here, this is xi, this is wi, I can put it as w1, w2, w3, and x1, x2, x3, if that makes it more specific. Now R is the level of the resource. If the level of the resource is for that activity, it had a certain resource load. Remember we said they have certain, so that is R, the resource load of that activity. And so based on this, you can see that if we are going to calculate the moment of the function of this histogram, I have just put it in an expanded form. So it is sigma xi, that is that is for each of the 3 bars in this particular case, sigma xi squared, okay. So it will be xi into xi by 2, so sigma xi squared half plus wi squared by 2, okay. So again xi squared by 2 plus wi squared by 2, and this is shown in this formula here. This is the moment before we shifted the activity. Now after shifting the activity, what has happened to xi is, here we go, this is 6, so this was at 7, so our amount of resources got taken away from this, and that our amount of resources got added to this. So what we are doing now is xi minus r, which is the amount it got reduced, that is here, okay, squared by 2 plus wi plus r, which is what got added here, squared by 2. Okay, so this is fairly simple. It's basically, this gives you moment 1 and the moment 2. Now we have these three options. So after the shift, either m1 can be equal to m2, which means there was no benefit no reduction in the moment by shifting, or m1 is less than m2. That means when I shifted, the moment of m2 became greater. That means this profile had a greater moment. If it had a greater moment, m1 would be less than m2, or m2 would be greater than m1, or we could have that before the shift the moment was more than after the shift. So which of these would you want to happen if you were going to actually do the shift? So if my moment before the shift was greater and after the shift it is less, this is the kind of sign I am looking for in order to be able to make the shift to the activity. So before I leave this slide, just kind of reviewing, because this forms the basis of the minimum moment algorithm, that we have a resource profile before shifting, we have a resource profile after shifting here, and we have only one activity for which we are shifting across. We are not going to shift multiple activities. The algorithm we are dealing with and the procedure we are dealing with does not involve at this stage shifting activities simultaneously. It involves shifting of a single activity. The resource load of that activity is R, okay, and that is R. Before shifting, the resource level on those particular days, okay, is xi, and before shifting, the resource level of the days to which you are going to shift to is wi. You are shifting by m days, okay. You have to be careful. We will later look at why we have to be careful with m. M is the number of days of resources that are removed. Please look at this. It's the number of days of resources. It's not the number of days of shifting. Okay, so this is a common problem when we start working out problems. We tend to think m is the number of days of shifting. It's not. It's the number of days of resource that are removed. So for example, here if I move this by 4 days, my activity duration is only 3. I'm only still shifting 3 days of resources. So m is 3 even though the shift might be 4 days. We will come to this later because this is a common problem in when we do these exercises. So please keep this in mind. So these are the variables, and remember we wanted this. So we talked that we ideally want m1 to be greater than m2. That is, after my shift, my resource load, my resource histogram has a lower moment. When we say this is, that means there is improvement in the histogram. Okay, this is what I want to try to achieve with the shift. If the shift does not result in an improvement in the histogram, it means that I should look for another alternative shift which might result in an improvement. This current shift doesn't. So if I take, again, put m1 on the left hand and m2 on the right hand. So these are the equations from the earlier slide. You then expand it, okay, collect, and you reformulate it, and you get what is classically known as the improvement factor formula. Okay, there will be a derivation for this. More details on the derivation I'll give it in the handout, but it would be good for you to go to the derivation, but it is equally important for you to understand what this formula basically implies. Okay, so here we have improvement factor of an activity moved by d days is the resource level of the activity, the sum of the resource load for the days from which was moved to the days it is going to be moved, okay, multiplied by the number of resource days that have been moved again into the resource load of the activity. So this is the improvement factor, and as you can imagine, improvement factor, what we would like to say here, it's kind of highlighted here, but improvement factor greater than 0 implies a reduction. Okay, if I calculate this improvement factor after a shift and show that it is greater than 0, and find that it is greater than 0, that means there is a reduction in the moment of the histogram. The improvement factor is equal to 0, then the moment of the histogram remains the same. If the improvement factor is less than 0, it means that my moment of the histogram has increased because of the shift. So this gives me an indicator whether I should make a shift or not. So the other point is that it is not just the reduction in the moment due to the shift, it is also a magnitude of change. So we are multiplying by r here, which gives you the magnitude of change of a shift. So this becomes important when we are comparing, when we want to compare between 2-3 activities. I shift one, I bring that one back, I shift the second one, might be both result in a positive value, in terms of improvement factor, but which gives you a higher reduction in moment will now depend on the resource level which is required. Okay, so that is what is, or the resource rate of the activity, that is what is R. So again, just revisiting these terms, okay, improvement factor for shifting is IF, daily resource rate for the activity. M is the minimum number of days activity shifted or the duration of the activity, the smaller minimum of number of days or duration. Like we said earlier, it is the number of resource days that were shifted from activities to the 2 activities. And Xi is the daily sum for current time frame, and Wi is the daily resource sum for the time frame over which the resource will be added. Okay, so it might take some time and some reviewing to understand these variables clearly, but also it will take some working out of exercises and reviewing it. So that is typical when we do minimum moment algorithm and its approach. Only through practice you will be able to understand and get a good feel of these variables and be able to apply it effectively to minimize, to kind of get a level, to try to level the resource profile.